Today, Renner here is going to help you do 17.1 equations of a circle. So when it comes to circles, we first need to go back to our algebra days. This is going to be very algebra intense, and we need to go back and think about what it means actually to be a function. And if you recall what it means to be a function, if I were to graph x and y here, just in this blank space, if I have some kind of weird line, I can tell if it's a function if there is a unique y value for every single x value, right? So if I plug in something for x, it gives me a single y value. One way to think of this is the line doesn't double back over itself. So you have like two lines, one over another. You always have, for each of these vertical y values, or x values, you have a single y value, right? So this would be a function. An example that is not a function would be something like this, right? Same sort of general shape. However, this is not a function because there's not a single unique y value for each x, right? If I said x is 0, you couldn't tell me what y is specifically. There's multiple options. So this wouldn't be a function. Another thing that tips us off to a function is if it has y equals. If you have this in your equation and there's no other y's, then it's going to be a function, and is a general rule. So my question for you is, Renner, you ready for this shape?
Yeah.
Okay, what shape is this?
Shape.
What shape is it?
Shape.
Is it a circle?
Circle.
It's a circle, yeah, that's right. Is a circle a function? Well, no, it's not, because it, for example, if I pick x equals 0, I get two different y values, right? So this isn't a function. So keep that in mind. The equation for a circle is not going to be a y equals. It's going to be something else. So we'll do our derivation of it here. And essentially we need to come up with something. The first few things we need to talk about are the radius. So we're going to define that circle as all points in the coordinate plane that is r distance away from the center. And the center we're going to give, it could be any value. And so in the coordinate plane, the center of that circle is going to be at hk, where h and k. Do you see the h and the k?
Oh.
Yeah, those are the x and y values respectively. Okay, so the center is at point C and has a radius of r. And then we have a point P. And point P is just going to be any point on that circle.
Oh, circle.
Circle, that's right. There's the circle.
Circle.
So we have point P, which is part of the circle. And we're going to give point P the values x and y, right? So for this equation, our x and y values will match up with the circle itself. Yeah. We are going to put in a third point here. Do you see the triangle? Where's the triangle?
No.
There's a triangle right here. See the triangle?
Oh, triangle.
Yeah, triangle.
Erase.
Can you say triangle? No, I'm not going to erase it. I just want to highlight point A here and explain that point A is directly to the right of point C and directly below point P. Therefore, the coordinates of point A are xk. And this makes sense. It has the same x value as point P, and it has the same y value as point C. So that's that reason. Haha, look at that. I quoted that exactly. Okay, let's go down and look at more circle stuff.
Oh.
Okay, so now we need the expression for the legs, right? So we're going to figure out the values of this length. What is the distance between A and C? Well, the difference between A and C, oh, here, let me put the point A here. It was x, comma, k. So that means this length, Renner, look. The length between A and C, the k doesn't change. So it's the difference between point A and point C is just the difference of h and x. And we actually don't care which one we subtract from which, because we're going to take the absolute value. So we could do x minus h or h minus x. Yeah. In this case, I'm going to do x minus h. And that means P to A is going to be the difference of y and k. So I'm going to do y minus k
K.
for that. Okay, so now that I have an expression for, let's see if I can do it in that. I have, this is what I come up with, x minus h. This one is y minus k. Yeah, I'm picking red, huh? Is that red? And then I know this distance is r.
Picking.
I know 3 sides of a right triangle. I'll help you. You can pick another color in a second. I have 3 sides of a right triangle. How can I relate those 3 sides? Well, I need to use the Pythagorean theorem, of course. So I can go down here. I use the Pythagorean theorem, which is a squared plus b squared equals c squared, or that thing squared plus that thing squared equals r squared. Now, what color do you want, Renner? Do you want green?
Green.
Or blue?
Green.
You want green? Okay, we'll do green.
Green.
This right here is our equation for a circle. So make sure you circle that, note that. It'll pop up elsewhere in your book. For example, it asks you to write it down here again. Why do you need absolute values when you write that? Well, it turns out all lengths are in absolute values. You can't have negative lengths. Suppose a circle has a center at the origin. What is that equation? Well, it's going to be the same equation, right? X minus h squared plus y minus k squared, however, equals r squared. Okay? I'm going to be quiet. Shh. H and k are both 0. So essentially, they just cancel out. And then we don't even need the parentheses anymore. So it's just x squared plus y squared equals r squared. Right? Whoa! I told you circles are just fancy triangles, but we use the Pythagorean theorem to basically come up with the equation of a circle. Right? So here's our equation of the circle. Again, you may want to note this one here. Do you want green again? I'll do green. You might want to note this equation because this is the one when the center is at the origin. All right, give me. Okay, so our equation of a circle. So we'll do some examples. This one here says that the center is at -2, 5. So we can simply. Renner, do you know what letter goes here? What letter is this? Is that an H?
No, letter.
Yeah, you got to say H.
No, letter.
And this one is a K.
K.
Okay, good job. So -2 is H, and 5 is K. And then the radius is 3, so R equals 3. And then we just plug these values in. It's an ugly R. We plug these values in for H and R. Keep in mind that if you subtract a negative, you end up with a positive, right? We're subtracting a -2. And so this comes out +2. And then the 3 squared, we just simplify. So I'll give you guys a second to do this one, this next one. So here's your pause screen. Okay, let's see what you got. Hopefully you got something like this. Where we have x minus 4 squared plus y plus 1 squared equals 5. Because the square root of 5 squared is 5. Cool. So that's pretty doable. Oh, I need another pause screen.
Oh.
Pause again.
Oh.
Okay. So hopefully you were able to figure out H and K and R from that and plug it into the formula and then simplify. We're moving on. And that is, we need to test sometimes if a point is on a circle. So their example here is they want you to prove whether or not this point is on the circle that is centered at the origin and contains this point. So the first thing we need to figure out is H and K, or the equation for the circle, really. Since it's centered at the origin, careful here. We don't want to think, oh, this is H, this is K, because those are points, or oh, this is H, this is K. It is centered at the origin, so therefore we're going to use the x squared plus y squared equals r squared. Well, we also need to figure out r. Shh, if you're going to watch, you got to be quiet.
Right.
Okay. So R is the distance between the center and the circle itself. In this case, the only point we know is on the center is this, and so the distance from the circle is 4. Because this point is 4 away. So R equals 4. And in fact, we can just write the whole equation right here by writing in a 16. 16, that's right. Is that a big number? Renner, I may have you count your fingers here in a second.
No.
So then we can put the center, when we graph this, we can put the center here, we can pick these points, and then we can draw our circle. And then we just want to check, is this point, is this point here on the circle? So I can just plug these values in for x and y. So is 3 squared plus the square root of 7 squared equal to 16? Question mark. Well, 3 squared is 9. The square root of 7 squared, 7 is 9 plus 7. Is that equal to 16?
No.
Yes.
Yes.
So we proved that they are that point is on the circle itself.
Yeah.
So they go through it here, but you get the point. Same sort of deal. We just did that. Okay. We'll try another one. We'll try B here. We need to prove that the point 1 square root 6 is on the circle. Prove or disprove. On the circle with center at -1, 0 and containing the point -1, 3. So we need the equation for that circle. Are you ready for a circle, Renner?
Yeah.
What color do you want? You want red, green? You want red this time?
Yes.
Okay.
Yeah.
Red. So the center is at -1, 0. So this is H. This is K. So the equation is going to be x minus h, so x plus 1 squared plus y squared equals the radius. So how far apart is the center and this point here? H's are the same. Shh. Too loud. Too loud. Too noisy. You gotta leave, okay? And the difference in the y values is 3. So we're gonna put a 9 here because that's 3 squared. So this is our equation. They draw a picture for us. The radius we've determined already is 3. And now we just need to plug in our values here into that and see if it comes out. So what is 1 plus 1 squared? Plus 1 squared. Renner, can you do 1 plus 1?
Yes.
What is the square root of 6 squared? Does that equal 9? Question mark. Keep it decent. So that's 2 squared plus 6. Does that equal 9? Does 4 plus 6 equal 9? No, it doesn't. So not equal. Therefore, no.
Dead.
No.
No.
It's not on that line. I skipped ahead some of this stuff. We can erase it, but we basically did the same thing without all the rigmarole.
Ow.
So I'm just going to erase these, and you can fill them in if you feel like it. But essentially, this is what we proved, right? Okay. See if you can do. Oh, no, okay. See if you can do this one here real quick. So pause. Yeah, did you see that? Is that a little minion? You should have gotten the equation of this circle is x squared plus y squared equals 36. And find out that 18 plus 16 does not equal 36, so therefore it doesn't lie on that circle. Okay, a few other questions. What information do you need in general? Well, as it turns out, you need the size of the circle, and then you need the center. And that's pretty much it. All right, say goodbye. Say bye-bye.
Bye.
Say bye-bye.
Bye.
Yeah, okay. Yep.